Okay, so this is the second video talking about special angle of 45 degrees. So we looked at a triangle that showed up when we moved 45 degrees from our starting position on the x-axis, so we ended up right here, and then we noticed that, hey, this angle is also going to be 45 degrees, which means that x and y are going to be equal, and when we plug them into x squared plus y squared equals 1, we found out that we came up with two numbers that when you square them and add them together, you get 1. So here's really easy to see, hey, look, if we square this, we get a half. If we square that, we get a half. If we add them together, we get 1. So those are the numbers that are equal sides here, but their squares add up to 1, satisfying Pythagoras' theorem. Now we said also that frequently we like to rationalize these numbers, so we multiply the top and bottom by root 2, so we end up getting something that looks like root 2 over 2 and root 2 over 2. Okay, so this is what we get at 45 degrees. Now, if we continue on, we'd be at 90, and then we'd be at 135. And you notice that if we're at 135, then we get a very similar triangle happening. This height here of our point, in fact, looks like the same as the y in the previous one. And this x, although it's to the left, is also going to be the same, and that's because if this is 135, then this little angle right in here, which is not how we talk about our triangle with that angle, but it is in there because we always start here and go this way, so we're actually at 135, but if we're looking at this triangle, there's a 45-degree angle in there, which means that's 45 degree, which means that these two sides are also of length 1 over root 2. So this point is going to have coordinates x root 2 over 2, except this time we have to say to go left, so that's going to be negative, and y is going to be positive root 2 over 2. If we add another 45 degrees, we're at this point right here, which was one of our nice points where we actually have the coordinate minus 1, 0, so we're not going to look at that. Go another 45 degrees, we're at 225, and again, this triangle here is going to be 45 and 45, so these two sides are going to be the same, so the x and y coordinates are the same. Now, x is negative and y is negative, so we get the point minus root 2 over 2 and minus root 2 over 2. So x and y are both negative there. Okay, another 45 gets us to 0 minus 1, and then another 45 gets us here to 315, and at 315 we're 45 degrees down here because another 45 degrees would take us to 360, which would be all the way around. So this is a 45 in here. If I draw this straight down, it'll be 45 in here. So by all the previous logic, the x coordinate is going to be root 2 over 2, and it is in the positive direction, and the y coordinate is going to be minus root 2 over 2. So we have 4 special angles corresponding to the middle of each quadrant where the x and y coordinates are the same, so they're both 1 over root 2, so that when you square them and add them together you get 1, and the sign you just have to take a look at. Did I go right? Yes, x is positive. Did I go down? Yes, y is negative, and like that. So this is our 45-degree points. All right, now, just to top it off, let's talk about radians. So we said 2 pi is all the way around, which means pi right here is halfway around, which means that half of halfway around is pi over 2, and half of that, again, right here is pi over 4. So pi over 4 is our 45 degrees. Another 45 gets us pi over 2, which isn't one of our nice angles. It's even better. And then here we have 3 pi over 2, or 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4. So the middle of our quadrant means that we've gone an odd number of pi over 4s, and evens land us right on the quadrant, so these points correspond with the odd numbers of pi's over 4, 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.